So let's say the black tiles represent where the horizontal threads go below, and the white tiles represent where the threads go above. So let's say we have 2 down and 3, 3 down and 2 ups, like so. And we have 2 shifts, which means the black dots will be shifted 2 tiles to the right, like so. And again, we have like so. All right. And another route will have it something like this. So you see the displacements between this column and this column is different. They are not the same like the horizontal threads, but now we have inconsistent displacement. So how do we solve this problem? Sometimes we have one tile displaced like this, and sometimes we have 2, and depending on your configuration, you may have like sometimes you have 2, sometimes you have 1, sometimes you have 3. This is a undetermined number of up and downs. So there is one solution to that is for each of these tiles, we will check the tile above and the tile below. If we have another black tile above, that means there is no transition whatsoever here. But if we have a white tile below, then this half tile will have to be a transition of some kind, right? And again, for this tile, we will check one tile above and one tile below. If the tile above is white, then half of this tile will have to be the transition. And if the tile below is black, that means we have no transition, right? Now, checking up and down like this is very complicated, and I figure out a way to make it simpler, is that this tile is exactly the same as this tile, okay? And this tile is exactly the same as this tile. So you see, this is exactly the shift number, right? This is the shift number to the right, and this is the shift number to the left. So from this tile, we look a number of tile to the right and another number of tile to the left, and check if these two are the black or white tile. It's a lot simpler than looking up and down. So that's the idea of how to displace the vertical threads. So anyway, let's go back to Blender and configure the nodes. Let's move this whole bunch downward. And yeah, let's configure the wiring. All right, let's continue. Now, the first thing we need to do is to offset this value by a z amount to the left and to the right. And to do that, we will use one subtract operation and one add operation. Okay, connect this one in like so, and we will connect the z value into these nodes. Okay, so we have this and this, but you see the offset kind of leaves some negative values, and here we have some very high values. That's not what we're looking for. So we need another floored modulo node to force these back into the correct range. So again, we will use the same modulo. Like that. And another one for the other node. Okay. So you see, this is the original modulo, and this one, you see, it's shifting to the right, and this one is shifting to the left. However, this one is checking the tile to the right, and this one is checking the tile to the left, so it's kind of work in reverse. Okay, next let's carry out the actual comparison. Create a less than node. There we go. And we will compare this with this x value, which is the up value. So connect this over like so, and don't forget to manage the wires. Otherwise, we will have a mess that is going to cause quite a bit of problems later on. Okay, another less than node, and this time compare this. So let's leave these two here for now. Next, let's go ahead and prepare for the displacement. So move these groups back a bit. It's going to be the fraction to the subtract here. Okay, move them back here, right? And we will separate x, y, z for this subtract node. Let's see the y. Okay, so we're going to be using this as a transition value for the up and down displacement. So again, this is a jagged displacement like this, so I'm gonna change it to something more curved using a float curve node like this. Okay. Now copy this separate XYZ node, and this time we will separate the fraction node. We will get something like this, okay? And create a math node, compare greater than 0.5 to get these alternating black and white bands. Now duplicate this math node and choose maximum, and combine it with the float curve here. And you see, now we have the lower half that has the transition and nothing for the top half, okay? And let's flip the input. And we need another version of this, but flipped to the top. So duplicate this math node, and we will flip this band using a subtract node. So before we have black and white, now we have white and black, okay? So now we have a flipped band like this. Okay, so we have these two like so. And using these 4 nodes, we can create the displacement for the vertical threads, up and down displacement, okay? So first let's create the downward displacement. So we're gonna maximum this with this, like that. All right, we have something like this. And another maximum with this. Okay, and finally we will multiply these together to get something like this, okay? So this will be our downward displacement, and right now it's upward. As you can see, it's greater than 0, so it's upward. We need to flip it down using a multiply by -1 to flip it downward. So right now everything is black because everything is below 0, so it's black, but really, in reality, it's below 0. And next, let's create the upward displacement. So duplicate these and use subtract. Connect these two like that. Okay, we basically flip these. Okay, we just flip white to black and black to white like so. And again, we will use the maximum node here and connect the the flipped value like so. So now we have this, okay? And again, we will multiply these together to have something like this, okay? So this is the downward displacement and this is the upward displacement. Now we need to combine these together. And to do that, we must first compare this x value once more. The up value, the x value here. And we will compare this modulo node with the up value. Like that. And this time we will use greater than comparison, okay? And we have this. Now we will use this as a factor to mix these two values together. So I'm going to connect this to the factor and connect this here. Okay, so now we have some very nice displacement. Here we have a 2-tile upward displacement, while here we have like 1 tile displacement. Okay, let's move things back a bit. And now, similar to this value here, we need to use a map range node to force it into 0 to 1 range. There we go. So now everything is in 0 to 1 range, and we got rid of all the negative values. Okay, so this is the displacement for the vertical threads, and this is the displacement for the horizontal threads. Okay, before we continue, let's go ahead and reorganize the wires. All right, we are almost there. Now it is time to actually displace the threads. We have the straight threads here, and we're going to be using these to displace the threads. But first, let's go back out here and increase the gaps in between the threads. All right. To displace the threads, we simply add this thread with the displacement. So choose add, and this is the vertical thread. We will add it with the vertical displacement, and for the horizontal thread, we will add it with the horizontal displacement, like that. And we have something like this, okay? And also, I don't want to add in between the gaps like this, so I need to get rid of the displacement in the gap. And to do that, we can simply compare these values with 0, like that. And again, compare the other threads. So we have these masks, like so, and we will multiply the displacement with this value, like that, and again the other displacement with the mask, like so. So now we have this thread like this and the horizontal threads like this, and we will combine the two thread channels together using a maximum node. There we go. So let's zoom in a little. So you see the horizontal thread is going above 3 vertical threads, and then go down by another 3, and then go up by 3. And let's check if the engine works correctly by changing these values. So let's say I want 3 up and 2 downs. There we go. We have 3 ups and 2 downs. Okay. And let's change the shift to 1. So it's a little hard to see now, but you can see the threads are shifting one vertical thread to the right. And let's try 2. And again, this is the begin of the up cycle, and this is the begin of the up cycle. So you see it's shifting 2 threads to the right. So everything is working correctly, and we have a nice displacement. Anyway, let's test the displacement by creating a shader. Let's say a diffuse shader, and create a bump map. There we go. Put this into the height and put this normal in like so. So you see the displacement is a little too strong, so let's reduce the displacement to something like, there we go. So now we're almost done. Let's go back here and increase this scale to make the threads a little smaller. Okay, and also decrease the displacement, I mean the height information. So you see now we have some very nice fabric texture going on here. The next thing we need to do is to develop the color for the threads, as well as the alpha and the other useful information such as the thread IDs to use later on.